Hello, welcome to the presentation of my research project. And in this presentation, I will demonstrate the preprocessing and artifact construction part of my research project, which is done by our programming language because of its high diversity in terms of libraries and preprocessing capabilities and um, exploratory data analysis capabilities, and I will demonstrate how I construct sequence parsing, scalar feature engineering, label attachment, and later prefix metadata builders and split metadata builders. And lastly, how we export them, which covers all the process all the way from Docker container script dataset to exporting them. So let's begin by loading the necessary libraries and feature initial observations. For example, some the capability system call lists can be represented as follows, which incorporates is it false or is it safe, or what is the name of the container escape image. Then later we can observe the some explanatory data analysis feature like unsafe rows, safe rows tend to have similar values in binary comparison, but it shows lack of information. What is the type of the attacks? It is very dull information, so we enrich it as we can show in the later of this presentation. And these are just some initial observations of the dataset. So let's move to the end of it, and let's run all the chunks above to see the important observations. Let's wait for a moment to run all of this. Then we will incorporate how it is working. It's processing a lot of different process, so we need to wait a little while because it is doing sequence parsing, as we can see from the previous outputs, and it is also doing some capability parsing like constructing capability vocabularies like demonstrated in here. Then it is doing some kind of scalar feature engineering, like their in numerical values take into account, because dataset is mostly constructed as string values or characters, so we need to turn them into numeric in order to feed into our machines. This is some error, not critic. And it starts to finish running, and we can check that yes, this is the prefix fractions we have construct like, and when we compare 25% of the fraction, the numbers of the safe is can be followed as this construction. How much is divided into each percentages, and these are some class enrichments we have done, like fine-grained attack family labels. As we talked previously, the dataset contains only two classes at first glance, benign or malicious, but we fine-grained it by using the previous feature engineering and parsing we have done, and constructed 6-class dataset by artificially implemented some preprocessing to dataset, and we keep the safe as is because it is not interesting, but divide the malicious, or in other words attack ones, into 5 different ones. The process injection, reverse cell, socket escape, host file system, mount, and sensitive file override with their representative figures. which shows more capability of machine learning algorithms in later stages when it comes to the modeling and evaluation, because they are not only predicting the how is it attack or not, but they are also detecting the class of it which is not available before. So the um, probable use cases of this research project covers more details at the end. We also incorporated another scenario like quartz attack families, which is the not divided or merged one of these classes. Process injection and reverse shell can group it in the runtime, and host file system mode and sensitive file override can be merged into file system escape. This came with some um, benefits and drawbacks. For example, you are using features like we have mentioned and say benefits of it, but getting more data for each class. There is a trade-off between them. We tested and experimented both, and select fine-grained one is an auto-train machine learning models and very capable of throwing features, and this is the early construction of the classes. There is also top atomic capability predictions like which capability added and dropped. For example, we dropped the duck override, set UID phone override, but added set some more set ID numbers and phoner features by dropping some of them, adding some of them. This is some processing we have done. Also, we calculate the entropy across attack families. For example, safe and sensitive file overrides tend to have high entropy when we look at the return value entropies, and reverse shell tend to have lowest entropy across them. In the system call, again, safe tend to have high entropy at the highest force, when host file mounts also show same now figures. Whereas in contrast, process injection tend to have lowest entropy, but in the return value it's centered in the middle. There is some differences in their entropy levels, which is also useful for machine learning for future predictions. This is also another kind of distributions figures, and at the end we are exporting them as we mentioned as before. The classes engineering we have done, we are exporting at the end. Thank you for listening. This is the preprocessing and artifact construction part of our research project.